how the network architecture will look like. Okay, so core distribution access. So when we plan for network designing, we will gather the business requirement. Okay, what does the business actually require? How many users? How many users will use phone, IP phone, or like how many servers will be installed? What kind of server is their requirement? Is it a database server, or some applications needs to be installed, or it's just going to be a file server where the storage of the files and documents or files or reports needs to be stored. So all these things will be gathered. When they initially share this many number of users is the requirement, then only we can plan for the number of switches in the access layer. So access layer is where directly the users will be. We call that as endpoints, or what to say, end users or endpoints will have direct access to the users. Okay, that is on the access layer. So, so the business need not invest a high-end switch model on the access layer to connect the users. There are switch models like 3750 or 3850 Cisco models, okay, which actually supports users and also works in the core layer. But that cannot be provisioned on the user level. A normal basic 2960, okay, 2960 or 3550 series and all can be placed on the access layer switches where only users can be connected. So based on the number of users, number of switches will be installed. So say I have a requirement for 500 users. Okay, so 500 users, let me put, if I want to purchase a 48 port switch, if I want to purchase a 48 port switch, then 500 divided by 48.
You're typing it or like I'm unable to see it?
No, I am calculating it. So for 500, so for 500 users, no, we need at least 10 48 port switch. Okay, 10 or say 11. Okay, 11 into 48 port switch. This can be, yeah, this needs to be purchased, 11 into 48 port switch. Okay, so when as the network architect, what he'll do, he will give the switch model to purchase this 1148 port switch to the business, or to the business who is responsible for that particular organization. But when they purchase, if there's a particular model, 48 port is not available, or the 24 port is available, then we need to change to a different design where it involves a 24 port switch, and accordingly the calculation will change. So at that time also, like there will be a redesign in the network. So anyways, whatever the architect is giving, no, the bill of material to purchase these switches, it might change based on the purchase. If it's not available in the market, then we need to go for an alternative product or alternative model design and all. So here we are going to place 11 switches. So not we are going to place exactly for 500 users, but we have to plan it for additional users. Okay, in the near future, in the next 6 months or 1 year, will there be any growth in the users count? Then we need to plan it prior. So additionally, what they'll do is they will put additional 2 or 3 more switches in advance in the design diagram. And that's how the purchase also will be done. And that is on the access layer. On the distribution layer is just optional only. In many organizations, the distribution layer is skipped actually. If not, they'll keep the distribution layer as it is, and they'll make sure they'll connect all the servers, no? The Windows or Linux server, whatever server is hosted on-premise, those servers will be connected to the distribution layer switches. And we need to make sure that all the access which is connected will have to be having a redundant port on both the distribution layer. It should be redundant. So this access layer switch will have two links connecting to two distribution disks. And this is not going to cause loop in the network. Why? Because this will be implemented with the spanning tree protocol, as well as two distribution layers switches will act as primary and backup. Primary or secondary, okay, or standby. HSRP will configure. So we need to make sure all the access switches have a fully redundant connection on both the distribution layer switches. Okay, so the cabling also needs to be planned in such a way that, say, this is just a typical diagram only, but doesn't mean that all the access layer switches are sitting in one floor. It can be on multiple floors. Okay, it can be on, because say a building has 10, 12 floors, and we have rented offices in that building on the second floor, third floor, seventh floor, 12th floor, like that only we will get. We will not get in the same sequence of floors. So based on the availability, we will get different floors. So we need to plan for different floors. Each floor should have connectivity to these two switches. Cabling and all, that's a different team. A cabling team, they'll do. There's a different people who work only on cabling, for cabling the network for organization. Okay, when they plan for constructing the floors for office purpose, the cabling also is done in that way. Redundant cables. Okay, so this could be a floor second, this could be a floor 7, floor 8, floor 12, likewise, access switches are placed. Okay. Distribution, like we said, it is only for servers. And make sure both the distribution layers, which is again should be having a redundant cable connectivity going to the core layer. Now, see, core layer, we call it as the backbone layer of the network. So it provides a connection to the distribution layer. So when it comes to a larger environment, when we see distribution layer, so it is just works as an aggregation point. It's an aggregator or acts as a service or a boundary between the access and the core. That's why we are placing only the servers on the distribution layer switches. Okay, it's not going to have any not special functions, but it's going to be a high-end switch. Okay, without any users connected, but important servers and all will be connected to the distribution layer. Core is where the routers will be connected. If we have a voice gateway, the voice gateways will be connected, right? And we can also eliminate the distribution layer, and we can directly connect the core and access layer directly, where we can put servers also in the core switches, because anyways, it's going to be a high-end switch where the ports and all will be like 1 gig port or 10 gig ports, the switch ports. So it's going to be a fast only. So servers, routers, switches, other switches and all can be connected to the core layer. So this is the hierarchical LAN design, right? For a organization, this is how it is planned. If the organization is very big,
The hierarchical design will be core layer, distribution layer, and access layer. That's it.
Yes, yes.
Okay.
Okay. So if you see this, like I explained, no, like core and distribution can be of one layer. That can also be done. And if the requirement is high, or say I want a redundant distribution layer switches, redundant. So one set of switches will be, one set of switches will be in the second floor. This set of switch will be in the fifth floor. And core switches and routers and all will be in the first floor. So redundant distribution. So if the floor, say if a specific floor, in that specific floor there's a power issue, power breakage or UPS issue, then what will happen? The links can be worked upon on the other floor where the other distribution or core is located. Okay, that's why they'll plan for redundancy in a very big organization. So this kind of topology can also be looked upon if there is a requirement of a many number of users or multiple floors. Okay. So this is one kind of a modular design, okay, with high scalability, right? So like I explained on the access layer, what devices can be connected on the access layer is a PC can be connected, okay? Video conferencing device in organizations and all, there will be meeting rooms with video conferencing device. So that can be connected, a printer can be connected, right? AP can be connected, an access point used for wireless. An access point can be connected on the access switches. A laptop, PC, an IP phone can be connected on the access switches. So there will be a door access, right? Door access. That device can also be connected to the access switches. So these devices and all can be utilized in the access layer itself. We need not go for connecting them in the distribution layer. It is not required at all. If we are going to connect on the distribution layer, then we are not using our devices efficiently. It will work, but we are not making use of the switch ports much efficiently. Just for connecting the user, it is of no use. No. So that's it. On the distribution layer, okay, like I said, on the distribution layer, access switches can be connected. The distribution layer devices or switches, the access layer switches can be connected. Service, high-end service can be connected. Okay. So on the core, it is very simple, only routers and distribution layer switches. I'll just give you, I was telling you about a very big enterprise office with multiple floors and all, right? I'll just give you one example. So, yeah. So this is all like 4 different buildings altogether, but works in a one, but works as a one office when it comes to network, one network. So between the buildings, definitely we need to place fiber optic cables only. Only fiber cables can run through 2 different buildings with that many distance to cover the distance. The normal Ethernet cables between the user and the switch, or between the switch and the distribution layer, a normal LAN Ethernet cable, a Cat6e, I guess is the latest cable now. So Cat6 cable can go to up to 100 meters of distance. That is the maximum distance that a Cat6 cable can be used to get the data from end user to the switch. Only 100 meters is the best coverage for Cat6 cable, a normal LAN Ethernet cable. But if you want to go for more distance, then we need to install a device repeater in between. Okay, that's going to boost the signal, or we need to like go for a hub, okay, which actually used to extend the LAN. From the hub again you need to connect the cables, or you need to place the access switch within that range. Only that is possible. If nothing is feasible, then we need to go for fiber cables only. That can cover up to 1 kilometers or up to 5 kilometers distance. Okay. So in that place only, based on the distance only, the cabling is also planned. How the cabling, what type of cables needs to be used. For this kind of test setup between the buildings and all, definitely a fiber cable only can be supported. Fiber optic cables, there are many specifications in fiber cables. Okay, because fiber cables and all will be more expensive. So based on the budget, we will, okay, which cable, which fiber we need to use and all should be planned by the network architect only. Okay, within the budget.
Do you have any notes regarding the information about these cables? Because this is a new topic for me.
Yeah, but I'm just
Yes,
explaining, but it's not included here actually regarding the cables and all. No,
okay.
it's not here. It's only
Like
the
what is the new
architecture.
one? It's category 6 or cat 6. What do you call it?
Cat6, yeah. Category 6 only,
Okay.
we call it as Cat6E.
Mm-hmm. Okay, so the switches present in the access layer are like catalyst switches, right?
Yeah,
Or
yeah. Access layer
Nexus
is catalyst switches, yes.
2960.
Right.
Okay. So it is used for connecting all the end users, printers, CPUs, and what else? I actually forgot what you told.
Okay. So on the access switches, what can be connected is user, like for the
Yeah,
user, it's going to be their desktop, laptop, their IP phone, a video conferencing
like Cisco
device.
Epiphone.
Yeah, Cisco IP phone, yes.
Like it is managed by CUCM certified union
Right, right,
CM.
right. You're right.
That one only, right?
That one only,
Okay.
yes.
Yeah. Okay.
Okay.
All
So
right. Got it.
Cisco itself has a video conferencing device we call it Cisco telepresence.
Okay.
That can be connected. Cisco AP can be connected.
Okay. So if you want 500 users, then we need to connect 1148 ports in one floor, or like it can be present in different levels of a
It can
building.
be on multiple floors. It is supposed to be on the multiple floors only. 11 switches has
Okay.
to be equally distributed. But
Okay.
we have planned only for the user count. But again, we need
Okay.
to calculate like how many will be having IP phones, how many rooms will have a video conferencing device, how many access points will be there. For the access points also, we need to allocate a port, right? So,
Yeah. So for
say,
access points, there are 3850 access point.
yeah.
Uh,
So access point in a floor, definitely we need to have some at least five access point based on the floor size.
okay. So all the access points are connected through wireless LAN controller.
Access points will not have a physical connectivity to the wireless WAN controller. Access points will be
They're
connected to
configured.
the access switches only.
Okay, so they're configured on wireless LAN controller.
Yeah, they are configured on the wireless LAN controller. The wire in the wireless WAN controller is also connected to the switch only. Maybe on the core switch
Okay.
or on the distribution switch, the access wireless controller is connected.
Yeah,
Right?
like
So the
9850, right?
communication between the access point and the controller is goes via the LAN only.
Okay.
Okay. Where the communication between the end users, if they want to connect wirelessly without any wired connection, they want to connect to the network, they used to connect through the access point. Say I am a laptop user, I'm sitting in my station and I'm working, workstation I'm working, and I want to go to the meeting room. So what I'll do, I'll carry my laptop, I'll go to the meeting room directly. Or I want to sit in the lobby and speak or to take some interviews. I want to get into the lobby or a different workspace. So I'll carry my laptop all over the floor, right? So at that time, when I'm not connected to the wired network, my laptop will be connecting directly to the AP. Based on the coverage, we have multiple APs in the same floor. So whenever I walk through or whenever I'm roaming, I'll be connecting to different APs, but I will not see the difference in the disconnection when my signals are getting transferred to one AP to other. There won't be any difference in the disconnection. Still, I'll be connected to the network. So user connecting to the
Okay.
AP is only wireless, okay, without any connection. But the Cisco AP with a wired connection to the switch and the controller is also connected to the switch. That's how the communication flows.
So if the switches are present in different uh, floors of a building, and there are a lot of devices that are connected to the switches. So in order to make this device communicate, we should use subnetting concept over here.
Subnetting concept is not required actually because we do subnetting based on the user's category. Okay, so say for example, if the users all are for marketing, then we'll put them in one VLAN. Based on subnet, we'll use subnetting concept, we'll put them in one VLAN. If the user belongs to accounting, put them in a different VLAN. Or if the users are belongs to finance, okay, put them in a different VLAN based on your requirement only. Or we can also plan them, the entire users put in one single VLAN, a very big VLAN. Okay, that is also possible, but mostly they will not put users in everybody in one big VLAN because there are chances of broadcasting. So we want to break that broadcast. So we are breaking that broadcast domain. We are splitting small networks, small subnets, putting them into VLANs. Okay. So that's the purpose for VLANs. So if there is any broadcast or collusion is happening in one IP range, so it is restricted only to that range. It is not going to spread it to a different VLAN or a different IP range. Say 10.10.10.1 is one range, okay, /24. In that, there's some user who's connecting a hub or they are trying to send broadcast messages to make the users to experience a slow network or something, then it is affected only on that VLAN. It is not going to cross between different VLANs. So in that way, we are just eliminating the broadcast domains, breaking them. So for that purpose, definitely we'll have to go for splitting the VLANs. 1 second, I'll be back. So where did I left? Yeah, on the VLANs part, yes. So that is the requirement for VLANs actually.
Yeah, I got it, but the point is how you're able to communicate between the devices present in different levels, different floors.
So the devices are not going to since the devices are all in the same VLAN, it is going to get the communication. See, example. Just forget about the floors, okay? This switch, where is that? Okay. So this switch has a direct connectivity to the distribution or core layer, right? Okay, the VLANs are configured here. So these two have a direct connectivity. So whatever VLANs, it can be a different VLAN also. But we have a SVI configured, inter-VLAN routing is enabled. So anyways, both the IP ranges are going to communicate. 10.10.10.1 is going to communicate with 10.20.20.20. That's enabled between these two switches. It's VLAN 10, it's VLAN 20. In the same example, if this switch is in the floor second and this switch is in the floor third, what's going to happen? It's of no difference. Even though it is physically located on different floors, still the cable's connectivity are going to the core and distribution layer only, right? So still there will be a connectivity. So users can sit on any floor, or switch can be placed in any floor. Still there will be connectivity. Why? Because we have a cabling done. It can be all the 4 switches can be of a single floor, or it can be of 4 different floors also. It's not going to impact the connectivity. So
Yeah, I got it.
this diagram is a typical architectural diagram. So in this diagram, for any organization, it will not show the floor representation and all. But you can go for, this is a high level design. When you want to go for a low level design, same way you need to prepare a diagram mentioning each switch name, IP address with the floor mentioned in it. Okay, with all the details that will come under low level design. This is a high level design. So architecture will design, okay, this is how the architecture topology should look like.
Yeah. So we are not using any routing protocols over here, right?
No. That comes after here, after this layer.